Hi, with this video we're going to take a look at a Fluke 87. We're going to also take a look at how to set that Fluke meter up with a min-max and a peak min-max. We'll look at frequency, we'll look at duty cycle. I've got the ATEC ignition module. This thing is working pretty good for us. I also have the picoscope hooked up. The top trace on the picoscope is the cam sensor. The bottom trace is one of the two crank sensors that this system has. So what I'm going to do first is connect the meter to my sensor output for my cam sensor. We're going to take a look and see what the voltage looks like. Now, I'm going to simply show you where the connections are, then I'm going to zoom in and we're going to take a look just at the meter. Okay, so here we go. I'm going to take my meter leads, and it's just convenient. I've got a banana kind of patch plug type connector here. Red lead is going to go on my sensor signal. Black lead is going to go on the sensor ground or the signal return, or whatever you want to call that. Okay, now, one thing I want to point out to you. Let me remove this. Again, this is the cam sensor. This is our top trace here. From the previous video, if you watched it, we saw that using the test lights, even the little 12 milliamp test light, it had an effect on that voltage. Now, you take a look at this, I'm pulling about 4.5 volts on that. When I put my meter lead onto that circuit, notice there was no change whatsoever in that signal. Now, there's the big reason why these DVOMs have at least 10 mega ohms of resistance in them, so that they do not affect the circuit that they are being used to measure. All right, so there's my push for 10 mega ohm DVOM. Okay, now I'm going to zoom in. What's that voltage telling us? Well, it's telling us something's changing. That's all it's telling us. Nice thing about a lot of these meters is you get an idea of kind of what's happening if we look at that lower bar graph. That thing's dancing all over the place. So I know I definitely have a changing voltage there. And I know we've got that with a scope pattern. I see I had a 5 volt square wave. So is this meter telling me I've got a good square wave? No, but it's telling me that I have activity on that sensor output. Now, I'm going to go ahead and change the leads to the crankshaft, and we'll take a look and see what we've got here. All right, it's moving, but it's not dancing nearly as much. We see this thing is keeping relatively stable, just a little bit over 2 volts. Okay? Now, one of the reasons there, we saw this from the previous video, is that we've got a whole lot more teeth on that crank gear, and it's spinning twice as fast as the cam gear. Okay, cam, only one tooth that's being looked at by that signal, so we see a much more notchy, if you will, or jumpy voltage. We switch back to the cam. And again, it's bouncing all over the place. We're going close to 0 volts on the display to up over 3.8. And again, you can see in the display here that it is bouncing all over the place. Okay, so at least I can determine if I've got some kind of activity. It doesn't tell me if it's right or wrong, just that there is some kind of activity there.